everybody. Welcome to the water quality portion of the Northwest Minnesota Water Festival. My name is Corey Hansen. I'm the water quality coordinator for the Red Lake Watershed District.
And hello, I'm Ashley Hitt, and I also work for the Red Lake Watershed District. Today we're talking about clean water and what makes water clean, and dirty water and what makes water dirty. We call this water quality. The quality of the water. Is it clean? Is it dirty? That's what we got to figure out.
Over the many years that we've been talking with students during the Northwest Minnesota Water Festivals, you have all shared with us all the different ways that you use clean water and why clean water is important to you, like drinking water, fishing, swimming, tubing behind a boat, tubing down a river, cooking, brushing our teeth, canoeing, kayaking, scuba diving, snorkeling, wakeboarding, squirt gun fights.
Squirt gun fights! Woo!
What is the closest river or lake to your home or school? Do you think that river or lake has clean water, or does it have some issues? Does the water look clear? Does it look brown? Does it look green even? Does it change throughout the year? Sometimes water quality in the same river can be very different during different times of the year.
What is good water quality? When we think of good water quality, we think of water that looks very clear, or water that we can easily see through. The water should have only very small amounts, if any, harmful pollutants. And the water should be safe for swimming, because we don't want to swim in water that would make us sick. And the water should have plenty of dissolved oxygen for aquatic life, or the fish, insects, clams, and other things that live in the water. And good water quality will support a thriving population of those fish and bugs, especially the types that like to live in good water quality conditions.
Now that you know about good water quality and what makes water clean and what we use clean water for, what do you think causes bad water quality or dirty water?
Now, poor water quality is often caused by pollution, and that's when things that are harmful, dirty, or toxic get into the water, and those are called pollutants, and they can create problems like muddy water, too much bacteria, which can make us sick, too much nutrients, which can lead to too much algae in the water, especially in lakes. And algae, they are a type of plant that doesn't have stems, roots, or leaves, but it floats around in the water and makes it look green, sometimes like pea soup if there gets to be too much of it. Bad water quality can sometimes have very little dissolved oxygen, and that can sometimes be a natural condition, but fish and other critters that live in the water need oxygen that is dissolved in the water in order to survive. In waters with the poor water quality, we also wouldn't find as many fish, or we might only find the kinds of fish that have adapted to live in those poor conditions.
Clean water makes it easier for fish to find their food. Dirty water makes it harder for fish to find their food and also covers up their habitat.
So when water becomes dirty, like this, that water would be really bad for fish, right? You definitely wouldn't want to swim in that water. How might this water be bad for plants? We know that there are a few things that plants need to grow. Plants need soil and nutrients, and it looks like there's a lot of that stuff in there. Plants need water as well, and looks like there's plenty of water in there. What might the plants be missing? To get an idea, let's compare a jar of clean water to this jar of dirty water. Plants need sunlight to grow, and the dirty water blocks the sunlight. So as you can see, it casts a shadow. It doesn't let much light through. And look at the clean water. Look at how much bright sunlight that lets go through the water.
So what might be making the water look dirty? What do you think is in this jar, making it look so dirty? You might call it mud, silt, sand, clay, sticks, leaves, even rocks. We have a word for this stuff that makes it all look dirty, and that's called sediment. One way that we quickly measure how much stuff, like sediment, is in the water is called turbidity. Turbidity makes water look cloudy, muddy, or even green. The higher the turbidity, the harder it is to see through the water. So turbidity is caused by all the sediment in that jar, or even algae in the water, that makes it look harder to see through.
How does sediment usually get into our rivers? Usually by the process of erosion, which is the process in which wind, water, and ice loosen and wear away earthen materials like soil that can move those pieces of sediment to rivers, lakes, and streams. Water can have a lot of power when it's moving. Water can move fast and it can wash away large riverbanks. Water erosion on a landscape can also create large gullies as it washes away the soil. How can we keep our sediment on the land and out of our rivers? Something natural that can be very effective at keeping soil in place and keeping it out of our streams and rivers and lakes is plants. What do plants have that helps keep the soil in place? Roots. Roots hold onto the soil. Plants themselves and their roots, especially if they're deep roots from native plants, help to provide armor for stream banks that protect them against very high flows that can cause lots of erosion. The plants themselves can also help filter water as it runs off of the landscape. Plants like trees, shrubs, and grasses that are planted along a stream or river or lake are called a buffer. When erosion is occurring on the land, the water that is carrying the sediment is slowed down by those plants that are planted as a buffer along the stream. When the water is slowed down, less sediment is carried into the streams and rivers.
State and local organizations collect samples and measurements of water quality to help us know which lakes and rivers are polluted, which then helps us decide which projects to put in what water bodies to help protect them. And we also need to know what water bodies have good water quality so we can make sure and keep them protected also.
There are some opportunities for volunteers to do many of the same measurements that professionals do. One example is the Secchi disc measurement. This is something that you can use on your lake, and you can get one of these discs from the Minnesota Pollution Control Agency or from a local agency like a Soil and Water Conservation District or a watershed district. And you bring this out into the lake in your boat and you lower this down into the water to see how far down into the water you can see this disc. And the further down into the water you can see the disc, the better the water quality, the cleaner, the clearer the water. And you can also share that data with other agencies, with the people that use the data to make decisions about what to do about a lake, which lakes need to be cleaned up, and which ones need to be protected.
So a Secchi tube is similar to a Secchi disc, but it is used to measure the water that comes from a river instead of from a lake. After big storms, sometimes sediment can be pushed into the rivers, and with the rivers having such high, fast-flowing waters, it really moves the sediment down the river. This is how we contain the sample to be able to read it to see if we can view the Secchi disc. And sometimes before rains, the water is so clear you can see the Secchi disc by looking through the top all the way to the bottom. But after the big rains and all the sediment moving through the river, we have to pull the Secchi disc up quite a ways before we can actually view it from the top of the water. So this piece of equipment is called a sonde. It was specially made to measure water quality in the water. We go on top of a bridge, we stand on top of a culvert, we put this directly into the water, and we can read on this hand pad what the dissolved oxygen is, what the temperature is at this exact moment.
We use a turbidimeter to measure turbidity. The turbidimeter will give us an exact number for the level of turbidity in our water sample. To use a turbidimeter, we collect a water sample, carefully fill our vial, and push the read button so it can shoot a beam of light through the sample to measure how much light is reflected by particles, or the little pieces of sediment that are floating in the water. If there is a lot of sediment, this could be bad for fish, and the turbidimeter reading will be very high. If there is very little sediment, this is good for fish, and the reading will be lower.
We also collect water samples and send them to a lab to learn more about the quality of the water in a stream or lake. And sometimes we can wade right into a river to collect the samples.
Sometimes when we're sampling a river, the water might be moving too fast for it to be safe to sample, might be too deep, or water might be moving really slowly. We don't want to disturb the bottom of the stream by wading in it. In those cases, we'll use something called a Van Dorn sampler. And this special piece of equipment will allow us to sample water without getting in the water. The way that works, we can stand on a bridge or a culvert. We can open up the ends of the sampler. And then lower it down into the water. Now, you see the sampler, it's got both the ends open. How is this going to hold water so we can bring it up? What this has is it has a special button on here that will release these. But how do we get that button to go down? Well, we're standing on the bridge and this is in the water. What I have here is a messenger weight. And we hold on to this while we're standing on the bridge. And so we can lower the sampler down into the water and then drop that messenger weight and close the sampler while it's in the water. And then we can bring it up and fill our sample bottles. Thank you for spending some time with us at the Northwest Minnesota Virtual Water Festival and our water quality station. We put together a worksheet for you that might be available in your packet from your teacher or available on a link in the notes below. And you'll get to do a crossword puzzle using some of the words that you learned today, and also do an activity where you'll get to measure water quality. Have fun.
Hello, future scientists! We're going to show you an experiment that you can try at home or in your classroom, in which you can see changes in water quality using something similar to the Secchi disc and Secchi tube that you saw earlier in this video. The materials you will need include a clear glass, water, flour, a spoon or something to stir the water with, and a printed copy of the crossword activity worksheet with the Secchi disc pattern. If you don't have a clear glass handy, you could also do this activity by cutting out the Secchi pattern and taping it to a coin, or by drawing a Secchi pattern on the bottom of a plastic cup. If you have a glass but don't have a printed copy of the instructions, you could draw your own quarter-size Secchi disc pattern on a piece of scratch paper. The front page of the worksheet has written instructions and a Secchi disc pattern that you will use for this experiment. Step 1. Fill a clear glass with water and place it over the Secchi disc pattern that is printed above the instructions on the worksheet. Step 2. Look straight down from the top of the glass through the water. Can you see the pattern clearly? Because your tap water is very clean, the pattern should be easy to see. If you can see the pattern clearly, your water has high transparency and low turbidity. Step 3. Take just a pinch of flour and stir it into the glass of water. This will be your sediment. It is okay to get creative and add other things, but flour works really well because it stays floating or suspended in the water. Step 4. Now, can you see the Secchi disc? Is it just a blurry shadow at the bottom? Can you see it at all? The little bits of flour are scattered throughout the glass of water, like sediment in a river or algae in a lake. And that makes it harder to see the Secchi disc. If you can see the disc, try stirring in another pinch of flour and see if you can still see the disc. If you can't see the disc, try pouring out a little of the water at a time until you can barely see it. As you pour water, you are also removing some of the sediment that blocks the view of the Secchi disc. If it's hard to see the Secchi disc, or you can only see it through a little bit of water, your water has low transparency and high turbidity. The flour increased turbidity and made it harder to see through the water. This low transparency could be bad for fish and bugs. Thank you again for spending some time with us at the Water Quality Station. We hope you enjoy the other stations of the Northwest Minnesota Virtual Water Festival.